Hello and welcome. In this video, I just walk you through how to define bins with respect to System Verilog Functional Coverage. So in the last video, we already had a discussion about the definition of bins, definition of cover point, cover group, how to define them and all. Now here in this particular video, we will try to understand what are different ways of specifying bins, and we will try to take one simple example of auto bins. Okay, so yesterday also we uh, saw this definitions, right, about the bins. So what is bins? Bins are used to keep the track, or you can say record, of number of times user hits a specific value of cover point expression. So let's say, for example, if we have a variable of 2-bit a, which is a logic type. So as you know, 2 raised to power 2 will be 4. So we can apply 0 to 3 value for this particular variable a. And for this uh, variable, if we want to define the cover point, so the simulator will automatically define the bins for this particular variable. And if we are not explicitly defined, then simulator will define bins like bin 0 to 3 for this particular value. So this is what the auto bin, implicit bin. If you are not defining the bins explicitly, simulator itself define the bins for the variable. Okay. And there is a concept called auto bin max. So by default, this auto bin max will be 64. We will try to see this auto bin max in the later videos. So for example, if a variable size is less than 64, the simulator will create the bins and there will not be any grouping. Okay. But if the variable size is greater than 64, let's say, for example, if we have 7 down to 0, 8-bit of variable, so 2 raised to power 8 to 56, right? So grouping will be there for that. Let's see here itself. So we have a variable a which is of 8-bit, so 2 raised to power 8, 6, 260, 256, right? 0 to 255 values we can apply for this particular value, and the grouping will happen for this particular variable. And how the grouping will be there: 256, the maximum size, divided by the 64, which is the default auto bin max, and the value will be 4. So the bins, you can see, for this particular variable will be like auto 0 to 3, then 4 to 7, and so on. We'll explore in the later video for to understand this auto bin max. And we can uh, explicitly define this auto bin max. We can override this auto bin max value also. Okay. So this is a sample cover group. Let's say we have a variable 7 down to 0, 8-bit x and y. So how to define the cover group for that? Cover group CG, end group, you can give any name for the cover group. I'm giving CG, end group CG. And for this cover group, we can define the option dot auto bin max is equal to, if you want to override that, we can define any value. Okay. And the cover point for these two variables will be cover point for this x variable, cover point for this y variable, and optionally you can define labels for them for these two cover points. So if we are not defining bins here, simulator itself will create the bins, and those bins refer as auto bins or implicit bins. So as we can define this auto bin max, option dot auto bin max, if we are defining this outside of this cover point or in the cover group, so this option dot auto bin max is equal to user defined value will be there for entire cover group. Okay. And we can define this option dot auto bin max for particular cover point also. So for this cover point, as you can see within the curly brace, we can define option dot auto bin max for this particular variable x and for this particular variable y. We will explore more about this in the later video. Now, if we want to define the explicit bins, how we can define? Let's say we have a variable x and y. The size of those two variables is 2-bit. So 2 raised to power 2, 4 bins will be there for each bin. So we can define the cover group, and inside this cover group we can define cover points for this particular variable a, and for this variable x and variable y, and in the curly brace we can define the bins for this x variable. How to define the scalar bin? You can see these are the scalar bins, and in the below you can see the vector bin. Okay, so let me explain what is scalar and vector bin here. So the syntax for that is bins, bins, and you can give any name. I'm giving b0 is equal to, in the curly brace we have to give let's say 0. So this b0 will be there for covering the 0 value. Similarly for b1 for covering a 1 value, b2 for covering 2 value, and b3 for covering third. If you want to define the vector bin, we can define something like this. Bins, you can give any name. I'm giving b, and empty square brackets is equal to the values or for this particular variable. So 0, 1, 2, 3 I can give, or you can give in the brackets 0 down to 3. So it will create 0, 1, 2, 3. How it will create? B of 0 to cover 0, B of 1 for covering this one, B of 2 for this 2, and so on. We'll see that vector bin creation in the next video. So this is what the summary, whatever things we have discussed till now. So the default auto bin max will be 64, and if we have if we have the values of the variables less than 64, then independent bins will be there. Less than or equal to, independent bins will be there. If the size of a variable is greater than 64, then grouping will be there. The maximum size divided by 64. Based on that, grouping will be there. And we discussed the scalar bins and vector bins. So how to define scalar bins? Bins is a keyword, and variable is equal to in the curly brace the value. So this is a single bin to cover 0 value. Similarly, a single bin you can define to cover 0 and 1, and you can define a single bins, let's say a, to cover 0, 1, 2, 3. Now in the vector bin, as I just showed you, that in the empty square bracket we have to define. So bins, you can give any name here, an empty square bracket. So how it will be there? A of 0, a of 2, a of 3, and so on. Now here, if we are giving a vector bin to, and we are defining the range something like 0 down to dollar symbol, it will take the lowest value to the maximum highest value. So for example, if a variable size is 3 down to 0, so 2 raised to power 4 is equal to 16, so 0 to 15, right? So minimum value is 0 and the maximum value 15 will be there. Similarly, you can define the minimum range is dollar, so it will take the minimum range to the maximum value if we have, and so on. Now let me show you how to define bins, how to write a code for that. If you are not defining bins implicitly, how the simulator will able to create the bins implicitly, auto bins. Okay. Let me jump to the EDA playground. So as you can see on this screen, I have written a very simple code. Module example end module. Inside this, I'm defining two variables like x, which is of 4-bit, and y, which is of 2-bit. So as you can see, for x 0 to 15 bins will be there, and for y 0 to 3 bins will be there. 2 raised to power 2 4, right? And 2 raised to power 4 16, 0 to 15. So for that I'm defining a cover group, name is CG, end group. Inside that, I'm giving option dot per instance is equal to 1 in order to get the detailed analysis of the coverage and coverage report. We have to give in ED playground option dot per instance is equal to 1. Okay. And it is for the entire cover group. We cannot define this option dot per instance is equal to 1 for the cover group. Remember this one. Now I am defining a cover point for this particular variable x and the cover point for this variable y, and optionally I'm giving a label x and y, and I'm not defining bins here explicitly, so simulator will implicitly create the bins name as auto bins. Within initial begin block, I'm allocating a memory for this cover group CG instance is C, right, for that, and I'm just repeating 50 times, giving a repeat loop for 50 times to generate the random values for this x and y variables, and just I'm calling a sample method in order to sample the coverage. And within another initial begin block, after 500 time unit, I'm calling $stop to suspend the simulation. Very simple example. Now if you run this code, you'll able to see the simulator will create 15 bins for x and 4 bins for this y value. Let me show you after running this. So as you can see here, it is creating auto bin 0 to 15. Okay, and for variable x and for variable y it is creating auto bin 0 to 3. Okay. And at least it should cover 1, and here we are giving repeat 50, and as you can see it is hitting more than once. So this particular value 0 is hitting 3 times, the 1 is hitting 6 times, and so on. That's why we are getting the 100% coverage for this x variable. Similarly, for this y variable, all the values are covered, all the values are hitting multiple times. That's why we are getting coverage 100%. Let's say if you just make it like 10, then you will see the coverage will reduce. Okay. So if you just run this code, you will see. So as you can see here, this bin 3 auto bin, right, is 3 is there, which is not hitting 0 times, it is hitting. So rest of 3 bins, bin 0, 1 and 2 are hitting multiple times. That's why we are getting 75%. Similarly here you can see we are getting 50% coverage for this x variable. So you can understand something like this, and the weighted coverage, we'll try to understand this weighted coverage in the later video. What is that weightage coverage? Weightage average for the coverage, we'll try to see in the later. So with this I hope you have understood, if we are not defining bins explicitly, how the simulator is itself able to create the bins, and so those bins we can refer as auto bins or implicit bins. And also I hope you enjoyed this video. So thanks for watching. Thank you.